If I zoom in close to the cylinder surface, let me zoom in like that, and I want to know what's the distance of this first mesh line from the cylinder surface. I'll turn on XYZ here, and let me zoom in a little bit more. And if I look at Y, which is the second number, it's 0.5 meters, which matches with, so that's a radius. And if I go to that, I will see that that's 0.504 meters. So that's 0.004, this distance, which is essentially 0.4% of the diameter of the cylinder. And that matches the Koei paper. So this mesh has very fine resolution near the cylinder. If I highlight mesh in the tree and go to statistics and expand statistics, I see that the number of elements is 18,432. That's a number of cells. In infinite volume, you would call those cells or control volumes. So the flow domain has been divided into 18,432 control volumes. And the solver will calculate. So let me turn off XYZ. I'll just pick that. The solver will calculate the two components of velocity and pressure at the center of each control volume. So the total number of unknowns is going to be 3 times that number. And the number of algebraic equations to be generated is also equal to that. So for instance, if I'm looking at this control volume, there'll be one equation coming from conservation of mass, one from conservation of x momentum, and another from conservation of y momentum. And so I'll have 3 equations per control volume, and the number of equations will match the number of unknowns. Save the project, and we are ready to go and set up the mathematical model in the solver and get the solver to solve that mathematical model.